What's going on, everybody? It's Mr. Gus, and I'm back in the chemistry classroom. Today, we're looking at lauric acid. All right, our lauric acid lab is it's a biological acid that has an interesting phase change. So today, you've asked questions about what specifically is taking place during a phase change. We've seen things melt. We saw it melt on the hot plate, and now we asked, what's going on during melting? So here's what we've done. We've gone ahead and we've taken this lauric acid, and I've gone ahead and actually frozen some these thermometers inside the lauric acid. So the lauric acid, I melted it down, and then I suspended thermometers in there. So now we can actually take the temperature, and you can kind of see it if I get really close. You can see through the dirty lauric acid test tube that right now this lauric acid is actually at 23.5, 24 degrees as it's sitting in here. So the way this thing is set up, I can take the temperature of just this solid as we apply heat to it, as we try to phase change this solid into a liquid, which we call melting, as we add heat to it. So I've actually already done this. I have a lab going right now where I've got two setups. I'll show you my setup real quick over here. So my setup is basically this. I've got a lauric acid tube in a hot bath, and I'm constantly taking temperature. All right, I'm kind of swishing it around. Right now, you can already see I've melted it enough where the solid is loose, and you can, oh, there it is. It just kind of broke free because it's melting. So it's only been on this hot plate for about a minute and a half, and the temperature is already up to 41 degrees. So the solid is warming up. I can still see solid in there. I can see some liquid lauric acid, but as it is melting, I'm watching this temperature increase. Now, as soon as that does melt, I'm going to add it to a cold water bath or a room temperature bath to bring the temperature back down. So I'm looking at the melting phase change and the freezing phase change or solidifying phase change. Over here, I've already conducted this experiment, and I have a completely melted lauric acid tube. I want to go ahead and place that in my cold water bath so that I can take that data. In this cold water bath, you can already see as I put it in there, it's getting cloudy in the bottom of the test tube. It's already freezing. And as it freezes, the temperature decreases. It's already back down to 52 degrees. Okay? So we'll pay close attention for a minute or two on these temperatures. But again, this one is currently freezing, and this one over here is currently melting. And as it still melts, I'm going to take a new temperature. Let's check back in on this melting one. Let's see. Swirl it up. As I swirl this thing up, the temperature is at about 43, 44 degrees, okay? And so that's curious. That temperature hasn't changed much since I started. Back over here where it's cooling, I can already feel that thermometer getting more stuck in there. It's cooling down in this bath here. As it cools down, I'm at about 47 degrees. So as it's cooling, it's at 47 degrees. It's freezing, it's at 47 degrees. And over here, it is still melting. And as it still melts, it's at also 47 degrees. That's weird. Oh, wait, hang on. It just broke free. So the thermometer just broke free. Now the thermometer is only in this hot lauric acid. And as it did that, I don't know if you can tell, as soon as it broke free, that lauric acid temperature jumped. I'm already at 71 degrees in this lauric acid. So as soon as the thermometer snapped off of the solid, the temperature just shot up, which is weird because it was sitting at 47 degrees. And as soon as it broke free, boom. And this guy over here is still freezing. It's in the solid. It's cooling down. And this temperature over here is still at 47 degrees. There's liquid in there. There's solid in there. It's freezing, but it's still stuck at 47 degrees. It's been there for a while. And this guy over here, now it's up to 78 degrees. This thing's temperature is changing like crazy, and this thing's temperature is being kind of annoying. Mr. Gustin, why did you make me do this lab if temperature is going to stay put? So this is weird, okay? I'm going to go ahead and turn these things off. I hope you get the gist of what I'm trying to get us to do in this lab, okay? Instead, now you've seen what the lab looks like. I'm going to go ahead and just show you what the data is that we've gathered. So this was observational stuff. I'm kind of observing what's taking place as the lauric acid is phase changing from either liquid to solid or solid to liquid. And here's what I end up seeing when I take all of my data. If you're in class, we took data every 10 seconds. We looked at the temperature to see what was going on. And what we noticed was that as this thing melted, there was a weird thing happening. As this thing melted and we started, its temperature started to increase until we got to that like 47 degrees Celsius point. At that point, it sat there forever until at a very certain point, we can say like it, quote unquote, we said it broke free. That thermometer broke free of the solid. It was no longer trapped in the solid. Now the thermometer was only in liquid, only in the liquid phase of that chemical. And we saw this thing shoot way up. We had this interesting like graph. Temperature was increasing, temperature was constant, temperature shot up as soon as all of that solid melted. That was weird. When we go back and we look at the freezing data, here's what we saw. It was a liquid, and as it was a liquid, its temperature started to decrease. And it decreased until it got to 47 degrees Celsius. I've seen that number before. That's a weird coincidence. I don't think things are coincidences in science. We've got to figure out why that is the same number. But as it got there, the whole time we were taking data, it kind of just sat at 47. As we saw the liquid turn into a solid, as we saw phases changing, this temperature stayed constant. And if we continued this lab like we did in class, or I can go take more data again, as soon as the thermometer became frozen and everything was frozen, there was no liquid left, we saw that temperature start to decrease again. I see this weird kind of combination between the melted lauric acid and the freezing of lauric acid. And what I see is that this like melting point and boiling point are both 47 degrees. That's pretty interesting. What I also see is that when the change is happening, these are my phase changes. When phase changes happen, I'm going to label phase changes. But when phase changes happen, apparently the temperature stops changing. So I need to ask myself why. What are some things I know about chemistry and some things I know about molecules? What questions might we have following this data? Following this experiment, what further questions might we have? What further testable or researchable questions might we have that we need to now address in class? So think about those things. Analyze this data however your teacher is asking you to analyze this data. But until then, see ya.